Back to OLS regression. Multiple OLS regression. It's called in the literature in certain places. In other places, it's called multivariate OLS regression. That's when we have more than one independent variable. So in this equation right here, we have two, right? It's depicted in this equation where we have x, b1x and b2x, right? So again, the beta subscript 0 is when the x's here are equal to 0, okay? And again, this is when we have two independent variables, okay? In your study, you will have more than two. You'll have 3 or 4, right? Independent variables. Okay. So any questions about this? Okay. So what I'd like you to do is open a stated data set, choose a dependent variable and a set of independent variables, choose up to 3, and type in or run a regression, right? By typing in reg and your dependent variable followed by your 2 or 3 independent variables. So I put it here for you actually, where your dependent variable is again net tuition revenue. Your first independent variable is state appropriations to higher education. The second one is full-time equivalent students. And the third one is state per capita income. Now, as you can see down here, you can actually save keystrokes, right? If you want to, by following, let's put this up here someplace, by following these commands here. So, or code. You type in global Y, and then within quotation marks, you put in whatever your Y is, your dependent variable is, and then global X, and you can put in several independent variables in here, right? They have, they have to be spaced, right? And they have to be contained within these quotes. And then you can type reg $Y, $X. They'll give you the same result. And you save keystrokes. So did you do that, Billy?
No, I didn't.
Okay. Okay. Yep. So the same data set that you were using before. And say this was your project, right? You can save that code here that you created, right? Make sure that you don't, whatever statement you put in here is preceded by an asterisk, right? But you would simply do a copy and paste into a do file. And I'll show you how to do that. Okay. So this is the result that you should get, right? So what we did here, we actually ran a multivariate pooled ordinary least square regression. Why do we call it pooled? Because we're pooling 50 states across 10 years. Okay? So that's a panel data set. 50 states across 10 years. And how would we interpret these results? How would we interpret these beta coefficients here? Let's start with state appropriations. Remember, this is our independent variable, net tuition revenue. So how would we interpret this first independent variable?
For every state appropriations that we increase, we drop, 0.66 of a unit in net tuition.
Right. I'll add something else here. Holding everything else constant. Okay? So that's something that we have to, when we present, always say, or when we write, always write. We're holding these other variables constant. We're not changing these. We're saying, holding these things constant. First, we have a negative relationship, and then we have specifically this value, right? For every dollar increase, there's a 66 cents decrease in net tuition revenue.
Are we getting the dollar increase from up there under residual? Is that,
No, when I said dollar increase, really this is based on how we entered the data. So if we have the data in both net tuition revenue and state appropriations in dollars, right? Then it's for every dollar, right? Versus say in thousands or thousands of dollars, right?
You can imagine state appropriations as the x-axis, so as it moves up, the line goes.
Yeah, net appropriations drop, right? Which kind of makes sense, right? Okay, so this is for FTE now, so it's positive relationship between net tuition revenue and FTE enrollment, full-time equivalent student enrollment, right? So that's expected, right? As you enroll more students, you get more revenue, right? Tuition revenue. This is per capita income, state per capita income. So this is saying, again, this is a positive relationship between net tuition revenue and per capita state income. Again, that would make sense, right? You would expect, well, if people have more income, they probably could pay more tuition. If they pay more tuition, institutions get more tuition revenue. Again, this is statewide, right? Okay. They're all statistically significant, right? P-value less than 0.001 for the first three here. For the constant, it's less than 0.01. Right. Again, we really don't care about the constant. Okay. Because really the constant is really saying when everything else here is equal to 0. That's not realistic, right? So we really don't care about the constant. Okay. We have the R squares here, the same we would have when we ran it with only one variable, one independent variable. Notice how the R squares would, well, you may have not noticed, but the R squares increase, usually increase the more independent variables you add. So one could say, well, we could add like 10 independent variables, 12, 13, 14, 1,000 independent variables, if we have enough number of cases. It's always 1 per 10, right? 10 cases. So theoretically, we could add 50 independent variables because we have 500 cases, 500 observations. But that wouldn't make sense for a couple of reasons. Well, the first is that, for practical purposes, who would want to collect data on 50 variables, right? The second thing is, this should be driven by some conceptual model, right? It should make sense with regard to what independent variables you're including in your model, right? You could add weather in there, average weather of the state in that particular year. Variables that don't make sense but have a relationship with the outcome, right? But that's not the purpose. The purpose is not really to pump up the R square. The purpose is to identify what? The independent variable of interest. Say this was the independent variable of interest. You want to identify that variable as being statistically significant, hence being important, right? Taking into account or controlling for these other variables. That's what you're trying to do, controlling for these other variables, right? Okay.
It also would probably get harder to align with the assumptions that they're all independent of each other if we have like 5 billion
Exactly.
variables.
Yes. And actually, when you do that, you run the risk of, and we won't really address this too much in this class, you run the risk of having some of them not being statistically significant, even though they're pumping up the R square, right? Because of that relationship between them. Multicollinearity, that's another mouthful, but that's the term when you have a lot of variables that are related, independent variables that are related to each other, and hence they're not statistically significant, but they also increase the R square. Okay. Any questions about this? Okay. Okay. I'll skip this. You can do it on your own, this exercise. All right? Because it's similar to what we just did, right? Okay. So, what if we think our dependent variables related to one or more continuous independent variables with a delayed temporal alignment? Well, so what does that mean, delayed temporal alignment? I can't get everything down here on this. See if I can do this so you can see it. Okay, I think you can see it now, right? This is a fancy way of saying that some of our variables are lagged by one time period. So think of it this way. And I'll try to use another example here that's than what is here. Think of enrollment as an outcome somewhere or across states. And that enrollment, first time, full time enrollment, say in four-year public institutions, may be related to the income of everyone in the state, measured by, say, the median family income of the previous year. Why of the previous year? Because particularly for folks who are enrolling their kids, their children, and those children are applying for financial aid, the financial aid is based on the previous year, right? So the median, you look at the median income of the previous year, right? So you may start out with enrollment in 2001, but you have to look at median income, family income in 2000, right? So that's a lag of 1 year. That is what we're referring to here, right? Another reason we might want to lag a variable is because we want to maybe avoid what's called reverse causality. So what's a example of reverse causality? You're looking at state appropriations and net tuition revenue. I always like to go back to that example. So when the state appropriates money for institutions, and we're saying, well, we want to look at net tuition revenue and how that might be affected by state appropriation. So we've already established that there might be some negative relationship, right? More money appropriated, less money, less tuition, you'd have to raise, right, as an institution. But what if the state says, well, we're going to appropriate money this year to institutions, by looking at how much they received from tuition in the prior year. Apparently, they could raise tuition and they could get revenue, right? So if they raised tuition in the prior year by a certain amount, we might give them less this year. So you see, that's reverse causation, right? So in order to avoid this reverse causality that might occur, we would lag, say, state appropriations 1 year, right? So in the previous example, the amount of net tuition revenue that higher education institutions in the state may now affect the amount of state appropriations, what I just said, and state policymakers decide to provide higher education institutions in the future. So the past can affect the future, but the future cannot affect the past. Unless, what's the name of that movie? The one, it's a famous, it's a classic movie with time travel, Back to the Future, right? That's the only way that the future can affect the past. Right. Okay. So if we believe this, then we can time lag, right? If we believe that the past can affect the future, then we can time lag one or more independent variables to avoid reverse causality. Of course, if we believe in time travel, we shouldn't do this. Okay. So using these time lags, we have to make sure the data are declared a time series, XD set year, or panel data set. This is what you'll be using. You have to declare it a panel data set to do this, okay? And that's the syntax that you would use. If you're using a panel data set, it would be XT set, say you're using state FIPS for the state IDs, and fiscal year FY, and you're doing it yearly. That's what you do, okay? And you would type in Stata, reg, net tuition, the variable, net tuition, the name of the variable, L1, meaning lag by 1 year, dot, state appropriations, L1 FTE, so it could be that the state says, well, we could give you, and this is the case of actually community colleges. The state looks at FTE enrollment in the previous year, right? And they give a certain percent of whatever it did in the previous year to the community colleges, right? So this is kind of a real thing. They actually look in the prior year, right? And you can also lag per capita income. I didn't in this case, I just left it unlagged. And this is what you would get, right? So this is net tuition revenue based on state appropriations lagged 1 year. If you wanted to lag it 2 year, you would simply put in L2 up here, right? Both here and here. Okay. So this is the relationship now, lagged 1 year. It's not contemporaneous anymore. The previous example was contemporaneous. This is lagged by a year. For these two variables, this one I kept as contemporaneous. Okay.
I put that in my Stata. What is model residual?
Oh, that's what it doesn't explain.
Okay.
Remember the E, Y equal X1 plus X2 plus E. E is the error, residual. Same thing. Error and residual, same thing. Okay. So I omitted what you just referred to because I didn't have space. So I just took it out, omitted that ANOVA table. And when you actually run your regressions, you don't have to show me the ANOVA tables either. I don't care. Most people don't care what the ANOVA tables show.
How do you interpret this with a lag?
The same way you would interpret with the contemporaneous, but you would say based on a previous year. So it would be the same thing, right? There's a negative relationship between net tuition revenue and state appropriation, but for every increase in state appropriations in the previous year, you have this reduction in net tuition revenue by 69 cents. Okay? Okay. I just lagged all of the independent variables, right? So it's the same thing, but I just lagged per capita income as well. Okay? So again, you would still interpret the p-values the same way, right? You get the same output, it's just that you're now lagging these variables, okay? So that's something you might want to consider if you're doing a correlation analysis where you think there might be reverse causality there, okay? And to avoid it, you just lag. Notice how I did this using the shorthand notation here. And this is another cool thing about Stata. If you don't want to key in all this in, over and over, and you have those global variables, right? You have the y global, which is the dependent variable, and you have the x, which is all of the independent variables. You can simply put in a lag here, right? To capture all of them. And it would automatically lag all of your independent variables by whatever you said here, 1 year of lag, okay? So everyone clear on the whole concept of lagging variables? You do that when you think there might be some reverse causality, right? You do that if you think conceptually it makes sense to do that, right? Because based on how the system works with regard to, say, financing, or with regard to, say, students enrolling based on their parents' income of the previous year, So it's what you think makes sense, right? That would determine whether or not you should lag independent variables, okay? Okay, now let's move on to interaction variables. These are also very important. Interaction variables, often referred to as interaction terms. So those two things are used interchangeably, a lot of inters here, in the literature, right? So they're a combination of independent variables. You could have two or more categorical. What are categorical? Categorical is when you have like a 0-1 variable, right? A state provides need-based aid only. So it could be a 0, it could be a 1, based on the state, right? Or the state is a member of a academic common market like SREB, MHEC, WICHE, and you code the state accordingly based on the membership in those different academic common markets. Right, it could be 1, 2, 3, 4, 1 meaning none, right? New York, Pennsylvania, New Jersey, Maryland, SREB gets a 2, and you down the line. So those are categorical variables, right? Two or more continuous variables, right? You're combining two or more categorical with two or more continuous, right? So the two or more continuous, basically, it could be, again, enrollment, which is a continuous variable, and the amount of aid, which is a continuous variable, or income, which is a continuous variable, right? You're combining the two. One or more categorical combined with one or more continuous variables. So you can combine a continuous with a categorical. That's an interaction variable. It's constructed to explain how the effect of one independent variable may differ with another independent variable. So what are we saying here? The slope may differ. So essentially we're saying the relationship differs, right, by the category, okay? Meaning the slope may differ. But we should carefully interpret these interaction variables. If you are doing a project which involves causal inference, you will be using an interaction variable. You will be using actually a combination of two or more categorical variables. The first one being treatment, the second one being whether or not treatment occurred, okay, a particular year post, right? We'll talk a little bit more about that. So this is how an equation with interaction variables would look. So the first part here where you have x1 and x2, that's familiar, right? From multiple regression, OLS regression. But we now add this combination of x1 and x2. That's the interaction variable. In your project, you might have an interaction variable that you want to show a difference with regard to the relationship of one variable to another variable and how that may differ, right? How that relationship may differ by utilizing an interaction variable. Or, as I said before, you're doing a causal inference and you want to show treatment post, right? So you have a treatment, particular state that's being treated, and you have another indicator for post-treatment, whether 0 prior to the treatment, 1 after the treatment, right? So you have these two categorical variables that you combine to see whether there's significance there. We'll get into the details of that later, right? But that's essentially what you're doing, okay? And this is actually a product of x1 and x2 here to adjust the adjustment of the slope of this slope, okay? So it's used to address questions such as, is the relationship between the dependent and independent variable nonlinear? Remember we had that x squared term showing the curvilinear? Okay. And we can actually get at that by multiplying, in essence, multiplying two variables, right? The same variable, right? Does the relationship, say, between state expenditures on need-based financial aid and student expenditures and state expenditures on merit-based aid differ by state governance of higher education? So now we introduce another variable there, state governance of higher education, which may be, it may be like Maryland, where it's both at the state level, right? To a certain extent, Maryland Higher Education Commission, but also at the system level, right? Versus, say, Michigan. Michigan is like laissez-faire. It's like every institution kind of, it's on its own, right, with regard to going to the governor asking for money. Whereas the University of Maryland College Park has to go through the system office. Coppin State University has to go through the system office, right? So there's another level of governance there. And the system office also creates policy for all the institutions within. Whereas in other states, it's very different, right? New York is another example. It's not only the higher education institutions that reports to the Board of Regents, but it's like all public institutions, high schools, education-related organizations report to the Board of Regents. So that is state governance of higher education and how this relationship, need-based aid and state expenditures on merit-based aid, might differ by the type of governance within the state, okay? So you get at that by creating an interaction variable between state governance, right, and say merit-based aid. That's a new variable. You didn't have to get more data because you say you already have data on state governance. You coded it, you have it in there in your data set, you have data on state expenditures for need-based aid and state expenditures. You have those data, they're in there, right? All you're doing is now telling state that you want to now combine what you have already, data on state governance, a code for the state type of governance, and you want to combine that with, say, merit-based financial aid to look at how the relationship between state expenditures on need-based aid and merit-based aid differs by the type of governance in the state. That's an interesting topic, actually. And I would accept an interaction variable as an additional variable. So again, you don't have to get more data. You already have it there. You're just creating telling Stata that you want to create a new variable, an interaction variable. So does the relationship between net tuition revenue and state appropriations differ, here's another example, by tuition setting authority. So tuition setting authority, some states, the institutions could set their own tuition. No one, for the most part, can prevent them from doing that, right? Other states, as Maryland is, you have a Board of Regents. They set the tuition policy, not University of Maryland College Park or Towson State University or Salisbury State or University of Maryland Eastern Shore. They can't set their tuition. They can request that their tuition be a certain level, but the Board of Regents for the University System of Maryland, they have the authority to set tuition, okay? Other states, it's the legislature you have to go to get the approval to set your tuition. So you may want to look at the relationship between, say, net tuition revenue and state appropriation, how it differs by tuition setting authority. Well, you get at that by creating this interaction variable, say between tuition setting authority, which is a categorical variable, and net tuition revenue or state appropriations, which is a continuous variable. Does everyone follow that here? Okay. So how do you do that in Stata? Very simple. We did it already with regard to looking at curvilinear, right? We simply put in C, period, state appropriations, hash mark, C, period, state appropriations. We created that in Stata, okay? To get the nonlinear relationship. But say we want to look at how the relationship, and let me move this down again. Sorry about that. I don't know a way of, let's put it someplace where we,
The more button, there's an option to hide it.
okay. And I can get it back easily?
Yeah, I think it'll. Control Alt Shift H.
That's a lot of,
Yeah,
Down,
floating
down.
meeting controls. It's like 4th or 5th from the bottom.
Keep going down, Dr. Titus, keep going,
Right
stop.
there.
there? Okay, great. And I can get it back.
Yeah. Now you just want to click back into your slide.
Okay. Thank you. Oops. Oops. Okay. Is that the one? Yes. Okay, so with this one, we want to look at the relationship between state appropriations. There's a relationship between state appropriations on state expenditures, on need-based financial aid, that should be financial aid, and state expenditures on merit-based financial aid differ by state governance. Here, state governance is whether or not it has a consolidated governing board, like New York has a consolidated governing board, right? And Maryland doesn't. We want to see if that relationship differs, right? So someone who's doing a project looking at enrollment and merit-based aid expenditures might want to know, well, does this relationship differ by state governance? Okay? Controlling for other things. We're not doing that here, but you could control for other things. So this is how you would set it up. Look at need as the independent variable, merit as the main, need as the dependent variable, merit as the main independent variable. We look at consolidated governing board, we call it GB. And then we look at how this relationship between merit and need differs by consolidated governing board. Now, because consolidated governing board is a categorical variable, we're going to put I in front of CGB, abbreviation for consolidated governing board, right? And we use that hash mark because that's telling Stata we're going to create this interaction variable. We get the same output, right? A ANOVA table, which we don't care about. This is what we care about, right? So we get merit. There's the negative relationship between merit and need, right? There is a negative relationship between whether or not a state has a consolidated governing board and need, right? So states with a consolidated governing board, less need. There's less need being, less dollars being spent on need. That's basically what this is saying, okay? Now this is saying it differs, however, by the relationship between merit and need differs by whether or not states have a consolidated governing board. Because what? It's statistically significant here. You can't go beyond that and talk about this value. You shouldn't, okay? You just have to look at the p-value here. You could look at this value, you know, and you can see that it's positive, and we're going to talk about that. But don't go beyond that with regard to the value, okay? Any questions about this? By the way, this gives you more to talk about. If you're looking at a relationship between some outcome and some main policy relevant independent variable, and you want to interact it with another variable, it gives you more to talk about. I had a professor who used to teach methods, and he said, when you do stuff like this, you have more numbers to wrap your words around, right? So hence you have more words, right? Okay. And again, when you do this, you're not really you're not creating in actuality a new variable here. It's kind of a virtual creation of a variable here, right? Because you're just combining this with this. So it's kind of a virtual variable. This is not going to show up. That variable is not going to show up in your data set. It'll only show up here when you run Stata, okay? So what does this look like? This is what it looks like, right? So what it's saying is, these are the fitted values of need, right? These are the values predicted by your model, okay? This is state expenditures on merit-based aid, right? That's your main independent variable, right? So as that increases for states with consolidated governing board, it's different, right? It seems to increase. But for states without consolidated governing board, 0, there's a decrease. Okay? So you might want to do this. You might, if you're doing a project like this and you're utilizing interaction variables to see how these things differ by the type of state governance, you might want to create a chart like this. It helps you to explain what you get in your Stata output, right?
So could you elaborate on like what the fitted value is on the previous table, like where we might see
Okay.
that, or?
So you're not going to see it. That's the first thing, unless you use another set of syntax. So after you run this, you can use a syntax that starts with predict, and I could show you if that you're interested in that, and that would create this fitted set of values
Gotcha.
in your data set. But you're not going to pick it up from here.
So essentially though, what we're graphing is sort of that interaction.
Yes.
Okay.
Yes, you're graphing the interaction here, and you're showing how it differs. The slope
Gotcha.
differs by the type of governing board that you have. So the relationship between the fitted values of need-based aid and state expenditures on merit-based aid differs, that relationship differs by the type of governance, state governance you have here. Okay? And that might be important to show. That might be, something that you're interested in. That might be part of your proposal, right? That you want to see this difference. Or you could create a new variable. Say you're interested in the share of, and I've seen this, the share of students by particular group, right? So you could have the share of minority students, right? Whether it's above a certain percent or below a certain percent, and see whether that share, right, also would differ by, how that relationship would differ by the share. So there are different ways of framing a research question to get at how you would look at the relationships and how they differ by some other variable, right? I would, however, recommend that you utilize a variable that's fairly easy to code. Like this is fairly easy to code. Or you can actually get this, I believe. You can do a search, a Google search, and someone has a database. David Tanberg, who he's the president of a university now, but he used to work for SHIO. I think he developed a data set showing states by consolidated governing board or type of governance, right?
This is kind of bigger picture question. When we're choosing what to control for, do we have to find research behind why we're choosing what we're controlling for?
I would say yes. My suggestion would be to look at what others have done, right? To kind of give you a sense of what to control for. So I would say, but don't spend too much time on that. And I always tell students, well, sometimes the controls come out as being statistically significant and your main variable may not, whether it's a treatment variable or whether it's a main policy-related or policy-relevant variable. That's okay, but you don't want to spend too much time talking about that because those are controls, right? They're not the main interest for you, okay? Okay. So here's another one. And with this one, I included tuition setting authority, right? So net tuition revenue, state appropriations, tuition setting authority. And I apologize ahead of time. I'll be using a lot of finance-related examples because that's my world. Finance.
I'm fine with that.
Okay. So in this particular example, we have the option, all base levels, and it just makes it easier, particularly if you have and I'll show you how to set up these labels for your variables and also your values, the coding that you use for the variables 0, 1, 1, 2, 3, 4 in the case of regional compacts or tuition setting authority. So when you do this, you have to establish a base reference group. So the base reference group for this particular example, where we have the tuition setting authority being the legislature, a statewide board, system board, or a campus, the base group is the legislature. So what we're doing, how we interpret this, is we're looking at how this is statewide board is really, we're looking at this compared to the legislature. The system board compared to the legislature. Campus compared to the legislature. You have to have a reference group.
How are they the reference or the base when there's no data there?
Yeah, you do have data. You put in your own data. So you would code. If you have tuition setting authority as a variable in there, right? You would have to manually go in and code each state. So Maryland would say this is 1, 2, 3, 4. Maryland would be coded a 3 because we have a system board as our tuition setting authority here in Maryland. Michigan would be coded a 4 because it has campus. Assuming this is 1, 2, 3, 4, right? So you have to go in and, okay, Michigan, 4, right? Florida, you would code as a 1 because the legislature sets tuition. So you would have to go in, you'd have to create this variable called tuition setting, call it, here it's called tuit set, right? And then, I'll show you how to create these value labels, but the values you'd have to put in for that variable, 1, 2, 3, 4.
And I think the question is also, why does it say 0 on
Where?
here?
Where? Oh, because that's the base. That's the base, right?
So it's like,
Unless you, I'm sorry, I have to correct myself. You coded base as 0. You coded legislature as 0. And you code this 1, 2, 3. So that's why. Yeah. So that's a good question, and I corrected myself if you coded 0, 1, 2, 0, 1, 2, 3. So the base is legislature, which is coded 0 in this case.
so how would we interpret this?
So with this, none of them are statistically significant in terms of net tuition revenue. So the statewide board, doesn't make a difference whether your state to tuition setting authority is statewide board. There's no relationship to tuition. System board, no relationship to net tuition revenue. Campus, no relationship to net tuition revenue. Compared to what? The legislature. So everything that you're talking about is compared to the legislature, right?
And this is all taken, like we're looking at state appropriations. Well,
No,
we're
no.
looking at like net tuition.
Net tuition is what you're looking at this as it relates to this. So there's no difference by tuition setting authority with regard to net tuition
Okay.
revenue. Again, it's comparing this to, of course, legislature, right?
So now assume, right, like obviously it's not statistically significant, but like maybe, I don't know, the system board turned out to be statistically significant. Like what would that number represent?
Remember, it's not the number, unless it's negative or positive, right? You don't have to
I see, okay, right. Because this
forget the number, right? You're just looking at the difference in the slope,
Gotcha.
right? So the first thing you would look at is this column here, whether it's statistically significant. P-value obviously is more than 0.05, so it's not statistically significant. Okay, here's another example, which I'm going to move now to a student level. Suppose you're looking at enrollment by race ethnicity. You would code race as ethnicity right here. So it could be 1 for, say the reference group is white, because usually the largest group is a reference group, white. And then you have Black or African American, Latino, Hispanic, / Hispanic, Asian, and all others, or whatever, however you code the race ethnicity, right? How you interpret that is the difference in enrollment by race ethnicity. If all of these, the p-value is more than 0.05, it doesn't make a difference in terms of race ethnicity. if one of them, say, I don't know, Hispanic Latino, shows that there is significance and there is a negative sign, it may mean that that relationship, that curve is pointing downwards, sloping downwards. So it means that there is less enrollment for that group, right? But once you control for other things, there may not be, right? Typically, that's how it's done. Here now, we combined tuition setting authority and state appropriations. This is interesting because sometimes when you do this combination, you may have an interaction effect. Here, you have an interaction effect between state appropriations and campus. So it differs when you look at campus compared to, again, legislature, but you're doing an interaction effect here. So sometimes you may not have a direct effect. This is the direct effect of campus, but you may have an indirect effect when you combine it with what? State appropriations. So again, you have something else to write about, right? There's no direct effect, but there's an indirect effect when you combine it, right?
So what would that, you would say there is a positive relationship, interaction?
Well, the indirect effect is the campus receiving more funding compared to the legislature tuition granting authority when you interacted with, that's net tuition revenue, when you interacted with state appropriations. So we don't know the relationship between these two in terms of a direct effect, right? Because that's not what we're looking at here. But we see the interaction. So we can say, well, if we don't look at this interaction, we may be missing something here. If we only look at the direct effect of state appropriations, we see that there's a negative effect. And campus, another direct effect, but it's not statistically significant. But the indirect effect is positive. So this number is added to that number, which reduces that number. I know that's a kind of a weird way of looking at it, but that's what you're doing. You're saying this added to this makes this less negative, right?
Okay, I think I get it.
If you look at campus authority along with state appropriations, it becomes less of a negative relationship.
Could you elaborate more on why we would add them? Like I can see how that would work and what we could claim from it, but why combine the coefficients there?
Because this, when you interact, right? And that's a good question, because when you're interacting these two, you're really saying this combined with this. Remember, you're combining this here.
Gotcha.
So you're taking this combined with this. That's statistically significant.
And you only combine it when it's statistically significant, and that's when it's less than 0.05?
You combine it based on your conceptual model. So you might be asking, well, your original question might be, what is the relationship between net tuition revenue and state appropriations, and how does it differ? So I'm breaking this down, right? And how does it differ by tuition setting authority? So it's more of a complex question because of that "and" that's in there, right? And that may be your research question. Now, if you see that this is not significant, you don't stop there. You still continue, because that's your research question, with these set of variables. Okay? And you might want to control for other variables, so you add these, but you don't do any combining here, right? Okay.
Bailey, maybe, were you asking about like the adding, like when you add them up?
Yeah.
Because I think technically, right, like you could add them, right, with the state appropriations and the statewide board and the system board, but that just doesn't serve any purpose because the
It's not
p-value doesn't
Yeah.
tell you anything, right? Like, so you
Okay.
could get a value, but the value is kind of junk information.
Right.
So there's just no point to waste the extra time, maybe?
Yeah, that's all right. That makes
Yeah, but remember, this is a direct effect. And some may argue, well, you're still missing something if you're only looking at one without the other, right? So if you look at just this, right, and then just that, you might say, oh, well, campus doesn't really make a difference whether you're a campus or not. You still, you know, net tuition revenue is still the same, right? Whether or not you're a campus setting authority, tuition setting authority. But as I said, you may want to go further with regard to how that differs, right? So some argue, and the argument could be made by you, that you should do that. You should look at this combination, because hidden in here may be this indirect effect.
Would another way of saying this be that if you have a campus setting authority, having the campus set your authority versus the legislature, raises the slope of state appropriations? Is that?
So, because, if you were to add them together, state appropriations and so state appropriations and net tuition have kind of like a negative effect, right? Like, as state appropriations increase, net tuition goes down a little because universities, don't necessarily need to raise it.
Right.
But on the campus level, if they're governed at the campus level, then you see much less of a decrease
Right.
in state appropriations when you consider the combination of legislative
Right.
governance and state
Right.
appropriations.
That's a good way of looking at it. Yes.
So the
Yes.
slope becomes less negative.
Right.
Right.
Exactly.
Yeah, it raises.
Yes. And when you add a positive to a negative, then
Okay.
the negative becomes less negative.
Yeah.
Yeah. If the positive is, the absolute value of the positive is less than the absolute value of the negative.
So you could maybe use this to say kind of like campuses, when they govern themselves, may run a little crazier with the tuition increases,
Right.
than like a system-wide board.
Right. Yes. Okay. You could also do this with double hash marks here. Is that time? Yeah. 1 minute. You could also do this with double hash marks here, showing it. Again, saving keystrokes. We just talked about that, right? I will not go over, because we're running out of time, margin and margins plot, but sometimes those can be used to further explain the difference in slopes, right? But it requires some more coding. Okay. Go over the next few slides. We've run out of time. I don't want to hold you here past 7 o'clock. So go over the next few slides. It's important to get an understanding of log transform data, particularly if you have non-normal data. You can go to the Elms to get an examples from the session. Okay, I encourage you to do that. We don't have time. I was going to have you rate this review of OLS regression.
There's a funny meme in here I'm seeing here.
What?
After the Slido, it's a funny meme.
Oh, yes. So the last thing is the humor here.